Welcome to Early Signal. Today, we're exploring a new development in energy storage that could reshape how we keep the lights on when renewable sources aren't available. Imagine a giant bubble filled with carbon dioxide, sitting quietly on an island in Italy. It's not just a curious structure. It's a breakthrough technology designed to store large amounts of clean energy for the power grid, ready to release it when the sun goes down or the wind stops blowing. This innovative system is called the CO2 battery, developed by a company named Energy Dome based in Milan. Unlike traditional batteries that rely on lithium or other metals, this technology uses carbon dioxide, not extracted from emissions or the air, but sourced pure and kept inside a sealed dome. The gas is compressed and cooled into a liquid and stored in pressure vessels, then expanded to drive a turbine and generate electricity when needed. This cycle can provide power continuously for about 10 hours at a time. Why does this matter? As we shift toward renewable energy, one of the biggest challenges is storing excess energy generated during sunny or windy periods to use later. Current lithium-ion battery systems can only store energy for about 4 to 8 hours, which often isn't enough to cover long nights or several days of low renewable output. The CO2 battery can extend that storage duration, potentially at a lower cost and with a longer lifespan than lithium-ion alternatives. In the short term, we're seeing rapid adoption plans. The first plant outside Italy will be built in India, followed by projects in the United States. Notably, Google has invested in this technology to power its data centers around the world with reliable, clean energy, even when renewables aren't producing. These facilities are designed to be modular and relatively quick to build, requiring flat land but no special geographic features. Over the next several years, if successful, CO2 batteries could become a common element of energy infrastructure globally. They don't rely on scarce minerals, they avoid some environmental impacts associated with lithium mining, and they can be scaled up to meet growing energy demands. This could help stabilize grids, reduce reliance on fossil fuel backup plants, and support deeper integration of renewables. Of course, there are some considerations. The physical size of these domes is quite large, and they occupy more land than a lithium-ion battery of comparable capacity. They also contain thousands of tons of CO2. If the dome is punctured, that gas would be released, though the amount is small compared to typical industrial emissions. The company has accounted for weather risks and emergency procedures, but community acceptance will be important. Looking ahead, the CO2 battery represents a promising option among a diverse set of long-duration energy storage technologies being explored worldwide. From compressed air to molten salt and pumped hydro to chemical fuels, the energy sector is experimenting with many solutions to the intermittency problem. What sets the CO2 battery apart is its blend of established physical principles with innovative engineering that prioritizes cost-effectiveness and scalability. In summary, as we seek to decarbonize our energy systems, breakthroughs like the CO2 battery offer a glimpse of a future where renewable energy can be stored and dispatched reliably without the constraints of current battery technologies. This could impact jobs by creating new industries around manufacturing and maintaining these systems, influence money flows by shifting investment toward long-duration storage infrastructure, and affect daily life by enabling cleaner, more stable power. Thanks for listening to Early Signal. Stay tuned as we continue to track this and other technology shifts that could quietly change the world.